we're going to get started in just a moment. So my name is ONeill. I'm one of the organisers for the evening. Tonight we've got Nick speaking and also Tony. And I'm just going to put you on to Tony from Discuss, who's going to tell you about Discuss, who's going to host for the evening.
Hey guys, thank you for coming out tonight. I'm really excited to host this event. Ida and Baron were a real pleasure to work with this event. And one thing I wanted to promote is in August 19th. August 19th, is that correct, Adam?
Yes.
There is a game night here at Discuss that you're all invited to join us. And also, we are also looking for any iOS developers. I have the approval of the CTO to mention that. So feel free to talk to the engineers. There's Jason in the back holding the beer, and also the guy pointing at him, Michael, and also Adam right here at the very back. So go say hi to them during the event, and hope you have a good evening. Thank you.
It's easier to talk to. Can you hear me?
Yes.
Excellent. Okay. I'm going to give you a little introduction to Swift Playgrounds today. Before I start, how many people here have used Objective-C before? Okay, a good number of you. And people who are programmers but not Apple format programmers. Okay, and then people who have no programming experience whatsoever. Excellent, excellent. I think Swift Playgrounds are actually an excellent way for people to start with programming if you're interested. Or Playgrounds are a great way to learn Swift in general. So anyway, getting started. My name is ONeill. I'm an iOS developer at Lunch Apps, which is my iOS contract development company. I do work for businesses in the city. This talk is going to be strikingly similar to a talk from WWDC 2014, 408 Swift Playgrounds. I'm going to cover most of what was in that talk in significantly less time. So if you have any issue with what you see and you want people to go over it pretty slowly, I would definitely watch that talk. The video's up on the Apple developer site, and you can check that out. So playgrounds are for prototyping in sort of a way that they're explicitly not for testing and explicitly not for performance. There's lots of stuff that Playgrounds does that makes it unsuitable for that sort of thing. What Playgrounds are great for is stuff like working with APIs. You can throw AF networking or whatever your favorite networking library is in there and make a request to an API, get back an object, play with it, figure it out before you build that into some sort of concrete, client class that you want to put in your next project. There's lots of great other things you can use Playgrounds for as well. You can use Playgrounds if you're doing lots of data transformation stuff like developing an algorithm to turn one set of data into another. It's really great because you can visualize all these little discrete chunks of information all along the way when you're transforming this data. And the last thing that I really think Swift Playgrounds are good for, and this is really what I based the talk around tonight, is developing custom views that you want to use in an application somewhere else. Usually we're used to this flow where we create a view and we have to build and run something, and you're running it in the simulator or you're putting it on your device. And you have to navigate to whatever view it is, and then you have to tap through to find it, and then you run it, and you're like, no, I want to tweak it just by that little bit. So you go back, you change a line of code, and you go through that whole process again. And Swift Playgrounds are really about connecting that and making that loop super tight so that you can change something and go back and see the effects immediately, and making that circle really tight. If you've seen any of Brett Victor's talks on dynamic visualization, Swift Playgrounds are obviously inspired by that immensely, and it really shows you. So, like all good talks, I'm going straight to demo. So, if we haven't used Swift Playgrounds before, I'll give a quick overview of what that looks like. For those of you using Xcode, left is standard Xcode editor. Formatting looks exactly as you expect it to be. And then right over here on the right side, we have a little thing called the sidebar. And then on the total right side, we have this little timeline thing here. Now, the sidebar is something that sticks around and provides you a little bit of a clue into what your code is doing line by line, whereas the timeline is sort of a more permanent thing. We'll see how both of these work as we get further into the block here. I'm really unsure about how deeply to go into this, so I'm going to give a real high-level overview of this whole core graphics, core animation stuff. It seems like a lot of you have experience with Objective-C, maybe not with Swift. So try not to fall asleep when I go through the core animation stuff. I just want to make sure everyone gets a good sense of what's going on. So we're importing the Cocoa framework here, which is a OS 10 UI library. If you guys are iOS framework or iOS engineers, I am also an iOS engineer, and my first instinct was to import UIKit here, but I'll show an important reason for why we have to do that at the moment, at least in the moment. Quartz Core is the stuff that brings over core graphics, core animation stuff, easy, and then XC Playground is the stuff that gives us a few important things that we need to use when we're playing with the playground and doing stuff like creating custom views. So we've got a class. It's a simple subclass of NSView, which, if you're not familiar, is just a super basic way to display information or display stuff in Cocoa. And CA shape layers, which you see below, are really, really basic drawing elements in core graphics. Basically have a path, you can give it some sort of background color, all this other nonsense. I'm sure if you people are familiar with any other programming language, there's something that does that sort of low-level drawing just like this does. I'm not going to cover a whole lot of Swift syntax, but init method does what init methods usually do. We're setting everything up here. So we set a bunch of sizes, and now, if you're an iOS engineer, you might say, what is this once layer thing? It's proof that CA layer is definitely bolted onto NSView if you're not familiar with OS 10 programming. And the layer-backed programming that you're very used to on iOS must be preceded by this whole once layer things for it to actually work. Anyway, it's something that hung me up for about 2 hours while I was porting this from UIKit to Cocoa. And now the meat and potatoes of this is actually drawing everything in core graphics and core animation. So we have 3 sets of layers here that show different things. We have a background layer, which gives us a nice little shape that we saw earlier. This is supposed to represent the clock icon on iOS, so you all should be fairly familiar with it. And if we check what that implementation is, suddenly we see something on the sidebar. Now this sidebar thing is telling us that we have 10 path elements that we created with this NS Bezier path creation thing here. And while that isn't terribly notable in itself, the 2 icons that are nearby are a quick look, which gives us that shape displayed right next to it, and a way to add that shape to the timeline. So if we want a more permanent idea of what that shape looks like, we can add it to the timeline, and then when we change something over here, mind you, I'm not saving here, I am strictly editing numbers. We can see those 2 shapes update pretty rapidly, and we don't have to build and run, we don't have to do any of this nonsense, it just goes as we're typing. So this is an excellent way for you to prototype doing lots of different shapes and tweaking all the parameters of everything you're building, and getting a pretty instant view of what that's going to look like on screen. So that is the background layer. It's pretty simple. Let's go up and enable the clock face layer. So the implementation of the face layer is pretty much the same. We've got some constants. You'll note that on the sidebar here, not only do we have a bunch of sidebar elements that are just telling us what constants we've defined, but we have this neat little one here that's actually telling us, we've done this math to figure out what the face radius is. And usually you'd have to go through and debug this, or nslog, or print line as it might be in Swift. But now you can just see it right on the sidebar here, so you don't have to guess at what that might be. You have that for reference, just by glancing at it. And then we make a path like we did before. We add some colors. And then we're setting up the numbers here along the clock face. Now, I'm not excellent in trigonometry, but I know, between cosine and sine, these are basically the things that I need to position my numbers around my clock face. And I can never remember which one's which. Which one starts at 1, which one starts at 0. So we use this little thing called capture value, which basically graphs a value every time you call it. And here we can see as we loop through this thing to see what hour it was, we got this nice little graph here. And I can see that the sine value, it starts at 1, not 0. That's why the first thing isn't at 0. But it ends at 0, which means it starts there too. So we can see that the sine value is actually the one that I wanted. That was the distinction for me. That's the one that I wanted to start when I determined the x and y position for these numbers. So let's say, you know what? Oh, actually, sorry, that was the cosine value. I know you trigonometry nerds were really sticking it to me there. Anyway, so let's say I really did want to see the sine value, and I don't want to see the autocomplete. So I changed that, and now the timeline view updates to show me the opposite thing that I was looking at. So let's say you're sitting there and you're trying to debug this series of values that you're creating to position items on the screen. And you know roughly the positions that you want. As you're changing this in code, you're seeing not only the current value as it's looping through and executing it, but you're seeing the past values that you tried before. So you can see how you're adjusting it, what the changes that you're making, the effects that they're making on your code. So that's part of the XC playground framework that I was mentioning earlier, and that's how you use XC capture value. So we position all the elements in the clock, throw them together with a nice little text, some fonts, and then we add all that stuff to the face layer. So finally, get rid of this, we get to the hands layer. And the implementation of the hands layer gives us another set of sidebar quick looks that we haven't seen before. In a state formatters, obviously we're creating a date here, that's today's date. Shows up right there on the sidebar, you can see what it is. And then as we're calculating the value between 0 and 2 pi that we want to position this around, we're just doing a little bit of math, and then we can see it right here. So we don't have to guess, we know that that's somewhere in the range that we're looking for. So it's roughly right. And then we just do a bunch of drawings to set up the rest of the looks for the center dots and the hands themselves. So draw the center, draw the paths for the center stuff, set up the minute hand, which is just creating a nice little rect. And then we take this little rotation here, which is, if you've used transforms on any sort of CA layer before, same thing. And we rotate this little rect around the center point there until it gets to precisely the angle we need it to be for the clock. Do the same thing with our hand, do the same thing with the second hand, and then we want to add a little bit of animation to the second hand. So essentially Swift playgrounds aren't supposed to execute for long periods of time. In fact, if you set up nothing else, Swift will execute exactly the amount of code that you have in the playground, and then it will promptly stop at the end and execute nothing else. Here, we want a little transform that has a duration 30 seconds, a linear timing function. I know that ease in, ease out functions are very popular these days, but clocks still work with the linear function, so we'll stick with that. And then we want to rotate it to essentially wherever we had it before, plus pi, which is the other side of the circle, right? Now, notably here, we have this little minus 0.001 here, and although CA or Core Graphics knows that radians only take up 2 pi, if you give it something to rotate exactly around the circle, due to rounding one way or another, it will choose whether to go clockwise or counterclockwise, whichever way is less for it. So we sort of help it along there by shortening and making sure that the clockwise direction is always shorter than the longwise direction. And then we add that all in to the hands layer. And I won't bore you with the whole making of recs with paths or converting NS Bezier paths to CG paths. But importantly, here at the end, you can see we create this little clock view here, and we can just quick look this clock view or add it right to the timeline. But if you notice, if we edit something, the quick view clock, or the simpler timeline clock we used, doesn't animate at all. The other one's animating, but this one's not animating. And that's because of what I was mentioning earlier about playgrounds, which is they execute exactly to the end and they completely stop. Now, we can add this other thing in here called XCP set execution should continue indefinitely, and get that to work a little bit longer. And that's super handy for async stuff like network requests. If you had AF networking in here and you were making a request and didn't use this, you'd be waiting for that block and nothing would execute, and you'd be like, why is that not working? And it's because it's reaching the end and then it's stopping. It's not waiting for stuff to execute that last block. So this should continue indefinitely. Works nicely with this timeline view over here. You can see 30 seconds here, which is the limit for how long the playground is going to execute. And let's set that back to 10 seconds to get a better sense of what's going on here. So we use this XCP show view, which captures a bit of the view essentially throughout the entire animation. And then when it's done executing, like it just did now, after 10 seconds, we can use this timeline view to flip back through all the past frames of this animation, right? So if you're doing a really complex animation that transitions between views or whatnot, and you have to go into your thing and build it and get to the screen, and then, it's quite a process. But if you can sit here and put your animation in storyboards, and then walk through it slowly and go back and forth and tweak something and then go back and forth, that's incredibly powerful for you. It saves you a ton of time when debugging your animations. So that is the last two things that we use for XC Playground, the XC Playground framework. And the reason I did this in Cocoa and not UIKit is because XCP showed you, for whatever reason, it's just not available on iOS with Beta 3. So if you're confused by why it's not showing up in the editor, that is why. And if you're an iOS programmer and you want to use it right now, it's not all that much different. You saw the CG graphics or the core graphics stuff that you're used to here, with the slight caveat that you need to convert your NS Bezier paths to CG paths with this song and dance I just showed you. So that is the demo for Playgrounds. Again, that's a lot of information in a very short amount of time, and if you flip through that hour-long presentation for 408 from WWDC this year, it contains a few things that I don't have, and also it's much more exhaustive in terms of explaining everything that's going on. So if you want to check this out, edit the code, play around with it, whatever, it's at GitHub. I believe this URL is on the Meetup event thing now, possibly. And again, I'm Nick ONeill. I have, you need to contact me for any reason, by all means. Happy to take questions about anything I showed you here today. I also have a little project that I'm working on. I traditionally do a lot of iOS stuff, Objective-C stuff, and I've been constantly wondering while I've been doing Swift stuff, what are the patterns that I've done in Objective-C that I can replicate in Swift? Are those similar? Are those different? So I've been sort of compiling them on a website called That Thing in Swift, which shows you code in Objective-C, the equivalent code in Swift, and if it's significantly different, why we would do it that way, as opposed to just porting over the existing stuff from Objective-C. So that's it. Thanks all very much.
Okay, thanks very much, Nick. We're going to take about a 5-minute break, and then we'll hear from Tony in just a bit. Oh, it's that in Swift, and I'll post his GitHub link on the page.
Where's the method? You'll always copy and paste it. No, like when it isn't beta, right? That's for alpha. They're on 3, right? It's got to be something missing here. There's too many people here, but this bracket is extra.
Okay, everybody, please take their seats. It's about to present.
Always go over it. I think you do it.
All right, Tony.
All right, everyone, we're getting going.
Hello? Hello? Can everybody hear me?
Yep, I can hear you. Yep.
All right.
What?
Okay, so after that first very polished presentation, mine's going to be a little bit more simpler. I'm going to show you how to write a basic Pong game, mainly because it was the first game I ever played when I was about 14, just a few years ago. And it's a pretty simple game, looking back there. And you would think that it would just take a few lines of code. So I'm basically going to go over what it took for me to actually build it. So I'm going to show you the final running product. It's not really finished yet, but you get the picture. And you can tell me the stuff to add, and you can critique the code, and you can hopefully learn something from this experience. And one thing I do ask is, the time this speech is done, and you have a look at the code and all that kind of good stuff, you just run home and start writing Swift code. Because if you don't, I'm going to taunt you, all of you. Because I'll tell you something, I'm actually an Android developer, and if I can write a Pong game in Swift, all you iOS guys better be able to do it. Okay, so this is my variation of the Pong game. When I learned it, it wasn't the Atari version, it was a 1980 version, which actually had color. So mine actually has a green background. Rather than play the game up here for you, I decided to just create the two paddles and then have the computer play it for you, moving the paddles up and down on both sides. So the first thing you need actually is a ball. So I'm going to do that just by pressing the button. And then basically, this is, I spent most of my time trying to get the realistic simulation of the ball to fly through the game. So you'll be surprised how little it took to do that.
Nice spin.
Now, there's a little problem there. It goes almost all the way to the right, but not quite, and then it bounces back the other way. And as far as I can tell, it's either a bug in my code or a SpriteKit. So, now I'm gonna try and drop it at different angles. You can see that the bug is pretty obvious there.
You start on the left and go right?
No. At the moment, it's hard-coded. This is not a sophisticated implementation. Now, I'll show you what I did in there. Maybe the bug would be obvious. So, the first question is how to do something like this in Swift. It turned out to be not terribly difficult. When you create the game, I use the technology of SpriteKit and then Swift, and of course you start off with your delegate, which in my case does absolutely nothing. The first thing I do when I'm developing source code, of course, is to put in a decent logger, so I can just watch the log window, and I'm not sitting there running the debugger or having to port it to the playground every 2 seconds. So there is an open source product I did use that actually prints out a nice debugger. It's a lot better than NSLog and nPrintline. Just allows you to print out a nice little debugger. So you can actually sit there and watch the debug window with me as I develop the code. Okay. Believe it or not, almost all the code is in this one file. It's called game scene. How many of you guys are familiar with SpriteKit? 1, 2, 3. Okay, so SpriteKit is basically Apple's technology for writing simple games. I'm not really convinced it's really industrial strength for like professional games, but for writing, for learning a new programming language or writing some cool, fun games to write, it is a lot of fun. Literally a 10-year-old can write games with this thing. So I figured it was good enough for me. Okay, so the first thing you want to do when writing a game like this is you want to create the bitmaps for the paddles, and you want to create the outlet. So what I did was I took basically a little white bitmap from the internet, shrunk it down with preview, and dropped it into my application. So almost everything here starts with this did move to view function. So this is the function that will be executed just once. This sets up everything, sets up the graphics, sets up the scene. So the concept here is that you have a scene, a game scene file, and then you go load a view to it. And and you're going to implement physics on in the individual views. Does that make sense? So the way SpriteKit works is everything's a sprite, so everything's an object by itself. So the left and right paddle are objects, the ball is an object, the ceiling and the floor are objects. All you have to do is set the properties to these objects, and you're sort of good to go. Okay? So my first thing I do here is I set up a left, right, and middle line. So here's the left and right paddle. You can see this it's an object with something called SKS sprint node. And then basically here I'm just loading the same white bitmap. Just everything's in white. So the graphics are really simple here. I don't even need an artist, even I can draw them, right? So the first thing I do is set up the paddles and I assign it to it. So there's just one line of code, gives me a nice variable, allows me to assign to a graphics. That's kind of cool, I think. Okay? The next thing I do is I set up a bunch of labels so I don't have to keep repeating these text all over my code. And then I set up what I call the ball speed and the paddle move speed, some of these like global variables I've used in my application. And then I set up something called collider type, which is an enum. I'll show you how to do that. This is for collision detection. Okay? And I'll get to that in a second here. So let's just go over this, how easy it is to write this. The first thing you do is create this game scene class, which this will all come with the generation of the game. So as soon as you say, I want to create a game in SpriteKit, it's going to churn up all these classes for you. All you got to do is fill in the blanks, right? So the first thing I do is I have a setup scene method. What I do is I set up my my scale node. So here I set it to fill. The books there is aspect fill, or there's like 4 different choices. Every one of them sort of seems to distort my view. So I just set it to fill, okay? And then I used to initially have a background color of green and load it as a bitmap, but that was kind of stupid, so I just set the color to green. So that's how I do my background green right there. So some of you are squinting, so I'm gonna zoom in a little bit. Is that better? All right. I kind of have an eyesight problem, so this is the kind of size I like as well, so. Okay? Okay, so that's the color. The next thing is to do is to set the ball physics for the velocity of the ball, so you have the ball rolling. So there's something called a physics world, which is assigned to every game scene. There's only one physics world, okay? So what I do is I assign the gravity, and I give it this, CG vector make, and you got an X and Y. So minus 18, minus 20, those magic numbers are just X and Y. That gets the ball rolling in a certain direction. In other words, it gets it rolling, the ball is not dropping straight down, it's not dropping to an angle, it's coming in this angled manner, okay? That's the physics world. The second thing is I wanted to adjust the speed of the ball, so this is actually the speed of the animation. When I first wrote this game, it was too fast. The ball was flying around like it was coming out of a gun. So what I do is I slow it down by 50%. That slows the whole simulation down by 50%. So now the ball's coming at a point where I can actually hit the ball, okay? And then there's something called the contact delegate. This is for collision. So when writing a game, there's 2 features you're always going to need. Because things are moving around on the screen, you need some kind of ability to do collision detection, okay? The second thing you need is you want to be able to create physics. Now physics was one of those classes I managed to avoid like the plague when I was a kid. So I don't know anything about physics, so I had to learn the basics of physics, because games use physics. So how the ball bounces, the effect of gravity, the effect of air, the angle it comes off, these are all features of gaming. So if you've got so writing most games includes developing, including a nice physics engine, and then a nice ability to detect when your bitmaps are colliding with each other. Now the cool thing is SpriteKit has both of those built in, and they're dead simple to use, okay? So this is the first one. So the contact delegate is just saying that I will handle, this class itself will handle the collision. I'll go a little faster here for some of you might be looking a little bored. So the first thing I'm going to do is add my structures. Okay, I call a function called add structures, and what I do is I create the floor and the ceiling. Okay, there's the line, vertical line. So I just load this bitmap, and I assign this, and I call this create floor, create ceiling methods. Some of this code you can explore online, so I won't go, line by line with it with you, but if you got any basic questions, I'll answer it for you. So how do you create a floor and a ceiling? This is basically how you do it. You create something called an SK sprint node. You create what you call an anchor point. It's usually 0, 0. So what that means is how it looks in perspective of the world view. Give it a name, and then you give it the all-important position, where you want it to show up. So this is the floor. Now the way it works in SpriteKit, 0, 0, the coordinates is in the bottom left. That's my understanding. So that's the opposite to almost every other thing. Okay? So you want to give it a position 0. Now the next thing you want to do is you give it a Z position. The Z position is in the 3D space. What that means is I'm going to have a bunch of these bitmaps. I don't want one bitmap behind the other one. So I give each one of them a Z position. 1, 2, 3, 4, and 5. Okay? The idea is that you are able to see all the bitmaps and not one is like overriding the other. Does that make sense? Make sense?
Yes.
Yeah? Next thing is physics. Now how easy is it to do physics with objects? It's dead simple. They have an attribute called physics body. I just give it in this particular case, this is a floor. I give it something called an edge loop from rec. This is like a static physics object. So it doesn't have a volume by itself. The physics is on the side of the floor. The idea is you only want to know when something hits the floor. You don't need to know what's on the other side of the floor. Okay? Now this is very important. You got to set dynamic to false. Okay? Because even though it's a built-in physics engine, if you set these values the wrong way, if you set it to true, and he thinks that the floor is going to start moving around, you're going to get all sorts of interesting effects, and they're all going to be wrong. So when you look at your objects, there's basically two different types. Ones that are moving and ones that are not moving. The ones that are not moving, you can make them dynamic and static, okay? And then give it a physics problem edge from rec, right? Which is basically the floor. Okay. Now there's something called a frame here. You'll see this floor.frame everywhere. Everything's occurring in a frame base, just like Flash. Everything in Swift comes in frames. So you're going to get up to 60 frames a second. Okay. So every frame, you'll be able to look at this frame attribute and look at the view, the width, and the height of every object. Okay. Two more things to cover here is the friction and the restitution. This is a ball. This is the floor. The friction means if something hits it, how much is it going to bounce away? How much is it going to slow down after being hit? Now this is a floor. I don't want it to move at all, so I give it a 0. The value is between 0 and 1. Restitution means how much is the bounciness of this. I don't want a bouncy floor, so I give it a 0. Okay. Now I want you to compare that with the ball. The ball is a simple object. It's not a sprite node. It's actually a base class called a shape node. Same kind of deal. Just a circle. You create like a circle. Have a position. It's not complicated, right? Give it a Z position that's not occupied by all the other ones. Give it a name, ball. Give it a color, white. I mean, this is kind of like code a 10-year-old can write, right? Now the physics is a little bit more intense because this is an object that's going to move, a dynamic object that's going to move. So instead of creating a static object here, I give it a radius of 20, which is the ball. I set dynamic to true because it's going to move. I set the friction because when it bounces off, I want it to slow down a little bit because of the gravity. I want it to, when it hits something, to bounce back as fast as if there was no wall. So I set a restitution of 1. So the reason for that, without that, what happens is the ball bounces and bounces, and every time it's slowly, the bounces get smaller and smaller and smaller until it's no longer bouncing. Now that's very realistic, but this is a game, right? So there's a difference between the physics and a game. So we want it to keep bouncing, okay? We set the mass of 1, so that's okay. Linear dampering, this is the effect also of moving through the air. Also 0. Resting is false. Affected by gravity. True. Now, I want this ball to have an initial thrust. So I call a property called apply impulse, and I give it an X and Y thrust. Now, if you're writing a game with rocket ships and missiles, you're going to have to give every one of these, your objects, some kind of physics and some kind of thrust. And then the angular vector is the angle of how it bounces off. Now, okay, so a couple more to cover here. Allow rotation equals false. I don't want my ball to rotate. And then there's a really cool property, guess what it does? Use precision collision detection equals true. Now, the reason they did that is that the initial one built into SpriteKit is not very accurate. I mean, sometimes my balls were passing through my paddle. If you set that one on, it checks it a little bit more often, 60 times a second, okay? So that's a lot to cover there, but it's not difficult, right? Once you set up all your physics for your ball, you have a bouncing ball that will bounce in any direction, and any angle you want it to, with any kind of velocity, and you can control what happens when it hits something, how far it bounces off something, and what angle it bounces off it, all by setting a few properties. Cool? Right? Most cases you have to include like a physics library and write a ton of code. Here you just have to set a few properties and off you go. Okay? Now, the last three things here that I'm covering for this object, I know it's kind of complicated and long, but this is for collision detection. So all the stuff up front there was all about how to make the ball bounce and all this kind of good stuff, how to make the ball bounce off walls, and what to do when it bounces. Now, how do you know when it collides? So you set these three properties: category bit mask, collision bit mask, and contact bit mask, contact test mask. So the first thing you do is you set something called collider pong.roar. Now, what on earth is this? These were all unions in the SpriteKit. Okay, so here's my enum that holds this value. You see that? So this is basically just like a little enum that I've created with Swift. These hold the different attributes. Excuse me. And what I'm going to do is I'm going to do some bitwise logic of them. So I know if I'm talking about the left paddle, the right paddle, the ball, the floor, the ceiling. What Pong is just the type. So in a complicated game, you would have like, these are the enemy types, these are the friend types, these are the character types, and all this kind of stuff. But this is a very, very simple game. So I'm only going to have one type, which is Pong, and then I'm going to have an attribute for each one of these, right? So that's how you create like an enum in Swift. Okay? Come back to that code. So what you do here, in your category bitmap, you just say, my category is Pong. I only have one category. Really simple, right? My collision bitmaps is for what objects are going to bounce into what. Okay? So I got a floor, ceiling, a right paddle, and a left paddle. And then the contact testing is which things are possible that can collide. And then I list all of them basically: ball, floor, a ceiling, a right, and a left paddle. Okay? By setting these three little bitmaps here, that tells the internal engine in SpriteKit what to do when these bitmaps collide. Okay? And then I have this little positioning thing which just makes the ball go through the air a little and gives a feeling of motion, so it has a little bit of a tail when it goes through the air.
Quick question. What is the vertical line there? Does that mean or what is that?
Yeah, so that's an OR. So I'm doing a bitwise OR. Yeah. So I'm just combining the types. So the contact test bitmaps is everything that is likely to collide. Okay, so okay. So you have to tell it what is going to collide, and you've got to tell it what is likely to collide and how you're going to deal with it. Okay. Left and right paddle are the same. I mean, they're not dynamic. Just set friction, use position, and set the Z position. That's it. So the static stuff is really simple. The only thing that's complicated maybe is the dynamic. Okay, so now we set up the physics. I mean, that was probably about 2/3 of the work there. Added structures. I set up my net. I set up the left and right paddle. So I call these functions here. If you notice, one function just calls another, and I just do all my setups here. I set up the left and right paddle. Okay. So the only real difference between one object and the other is that is what type of physics body you decide to do. Is it dynamic? Is it static? Is it moving? Is it not moving? Is it going to collide? Or is it? But notice only the ball has the collision stuff. Because only the ball's going to collapse stuff. Okay. So once you got all that thing set up, I mean, yes, it does take a while to get up to speed and learn all that stuff, but everything else was kind of simple. So what happens is when things collide, it will call this did begin contact method and did begin end. So these are two functions. So when it starts to collide, it will call one did begin commit and did contact end. If you want to learn how long it collided, then you have to set like a little timer and you have to measure it. Okay. Now, some of you are probably rolling your eyes. If you're not into writing games, I mean, some of this stuff looks esoteric, but it's, for me, writing this game was a way of me to learn Swift, and it certainly helped. Okay. The other functions, there's a few more override functions you'd be aware of. The way it works is a frame, so it cycles through about 5 or 6 of these functions in every frame. So these functions like just before I'm about to draw, just after I draw, just before I'm about to apply the physics, right after I apply the physics. So you have all these functions it keeps calling in this order. All you got to do is hook yourself to the framework, override these functions, and put your code in. That's it. So there's a function called did simulate physics. I love the name of these functions. So this is a way of in this function what I do is I tell it to, I check to see if you're coming off the screen. If you're coming off the screen, I remove the ball. Okay? I do this in kind of an interesting way. Oops. I'm not sure you can see that. The last line of code is self-enumerated child with named ball, and I call it block. And then in the block above it, this is where I check to see where the ball is. So if your Y is coming off the Y, the left or the right side, then I make sure to remove you. Okay? So the way I launch the ball is through the touches. So what I would do is in a real game, you would program the touch of the two paddles, move them up and down. In this particular case, I just did the touches begin, and here this is how I launch the ball. So I create my ball and I launch it. Okay? Remember the physics world has the ability to move the ball, and the ball itself has initial velocity. Okay? It's simple, right? I mean, that's kind of it for the game, really. I mean, the only complicated now bit is the bitmap collision. But before I do that, I'll take questions if you guys have any.
How did you debug this? Just debug? Does this work with Playground? SpriteKit and Playground? Can you use that?
You know, it's Playground's a really cool thing, but I must be a really old guy because I just debug this line by line, and with my log statements and writing the code and then running the game over and over and over again. Mainly because obviously Playground would have definitely helped in a lot of this, but I thought I would be involving multiple files, and Playground is more sort of suited. It seems to be suited for like everything in one spot right up front. But in retrospect, I would have saved myself several hours if I'd used Playground. So do use Playground to build these games. Okay.
Another question, I think?
Any other question?
Yeah, so it might be a bit basic, forgive me, I'm not a programmer, but it seemed that the ball in your demo was a bit overly affected by gravity.
Mm-hmm.
And can you describe what would happen if you were to turn off the ball being affected by gravity? So if you could just launch it with some initial velocity and then just have it bounce off the side of the house alone with no
Well,
gravity.
I mean, it's actually programmed not to be affected by gravity, but it still seems to be. So there seems to be, the way you do that is you can say,
But is this affected by gravity true?
yeah, okay, that just means that if I turn that off, the ball's not gonna drop.
It won't move anywhere.
It won't move anywhere.
Gotcha.
It will just sort of hover in midair, like it's got wings. So it's a ball. So all my other stuff does not, gravity does not affect, but even though I turn off the effect of gravity by setting the restitution, the friction to low values, people expect balls to drop. So you have to give it a realistic simulation, it has to have some effect of gravity. Any other questions?
So did you, like how long did it take you to write this if you were just learning Swift? And have you written any other game before?
I'd say I got about 10 hours of coding into this. Have I ever written code before? I've never written any, I've written very few iOS apps before. But all joking aside, I used to be a Flash game developer, so I do have the background for this. So if you're new to programming, it's it might be a little challenging up front. It was even for myself learning this, but once you get going, the frameworks help you. The language itself helps you. It's dead simple. You just have to be patient. You have to learn the language and you have to write code. The most important thing I need to pass to you guys is this. Do not learn Swift by reading the manual and going to one lecture after another. Okay? Open up, download Xcode, install it, and start writing something significant. Okay? Without that, you won't have that hands-on experience. And that hands-on experience is absolutely critical. Basically, this is learning what they call the hard way. Okay. Looks like I'm almost out of time. If I do have some time, I'll cover how I do the bitmap collisions, if you're interested. Everyone want to see that or not?
Do you have any idea where the bug may be, where it doesn't collide and it comes back?
Yeah, it's the physics. It seems like I had to resize my view, make the physics body bigger than the view. So right now my physics body is the size of the view, but what seems to be is like my physics body is actually thinks that it's like inside the line when it really should be a little bit out. So by resizing the physics body dynamically, then it will fix that bug.
Can I make another suggestion?
Yeah.
Switch the gravity.
I'm sorry.
Switch the gravity to the other side.
Switch the gravity to the other side.
Whenever there's a collision. That's what it's doing.
Yeah,
But-
see, what I do with the velocity here is when the ball bounces, if it hits something, I increase the velocity of the ball. So if you hit the right left pedal hits it, I want it to go away faster, right? So I do it by doing this, by increasing the body velocity. I have tried that. I have actually increased the velocity to ridiculous amounts, but it seems to it's constrained by the physics. So it gets almost to the end, and then there seems to be a line of code that's stopping you from hitting that right side. Any other question? Yes. Yes.
Hey, you may have covered this, but when you're initializing your gravity, why is it so negative?
Just go to the left.
But if you're also adding an impulse, why do you need both a negative gravity and an impulse in a different direction?
Okay, the negative gravity is a physics world thing, so that just makes that the ball will fall down in the physics world at a certain angle with a certain velocity. The impulse gives it the initial energy. So some of those stuff is made for like rocket ship games and that kind of stuff where you want the rocket ship to smash into into something and then bounce off at a different angle and rocket away in a different angle. So that's why they got values like impulse thrust and angular velocity. So mine's a little simpler. I just want this ball to drop in a realistic manner. I don't want it to drop straight down. I want to drop as an angle.
Okay, thanks very much, Tony.
Yeah, what if on GitHub everybody's interested?
Yeah, so the code will be on GitHub, so if anyone wants to fork it, and maybe by next meetup we can sort of fix the bug and get it running. Cool. So what's happening now, anyone who's interested, we're going to break you guys up into groups of 2 or 3, and we're sort of going to give little projects for you guys to work on between now and next meetup. You don't have to be involved with that, but it's a great sort of hands-on experience, so you guys can sort of team up and do something together. So stick around if you want to be involved in that. Otherwise, that was the last talk of the evening. Thanks very much for coming.